All right, my AB kids, we are ready for section 7.3 on sketching slope fields. This is a whole different ball game. It's kind of fun to be able to see what a graph could look like just based off of a whole bunch of little slope lines. And so that's pretty much what this is all about. Slope field represents a differential equation, in other words, a slope, obviously, on an xy plane. Here it is. It shows the slope of all the particular solutions to the differential equation. Now, what the heck does that mean? That's a lot of math talk there. But here's the story. If you were to take the derivative equaling 2x and go backwards to figure out what's the function, if the derivative's 2x, what's the function, you say? If I were to do that, all I need to do is integrate, right? I'm going backwards, so I'm going to integrate. What's the integral of 2x? And so if I integrate that, then I know that the actual function is the function x squared. It would be 2x to one more power divided by the power, the 2's cancel, plus some constant. It could be vertically shifted some way. And we talked about that in previous sections. So I look at this slope field, and sure enough, it's like almost like a cattle chute, it reminds me of. I think that he used the reference of a leaf in a river or something. Where's the leaf going? Where's the current pushing it? But I tend to think of it like a cattle chute. Like, you know how you sometimes like that you've got to stay between the lanes, right? And so if I look at this and I kind of stay between the lanes, it looks like this. Well, isn't that an x squared graph? Or maybe I might want to move down a little bit. Let me change my color. Maybe I'm down here making my turn. Those are both x squared graphs. They're just in different vertical locations. And so that's what these slope fields do. They help me to figure out what the actual function would have looked like. So if the slope field is 2x, which this one is, what was the function? Stay within the cattle chute, and that'll show you what the function is. I believe that he said something like you can choose a coordinate. He chose a coordinate that was -1, 1. And so that means that if that's the coordinate we're looking at, then dy over dx is 2 times my x, -1, or -2. Let's go to that coordinate and see. If I'm at -1, 1, I am in this kind of area. Is the slope about a -2? And that is true. So this one's telling me what the slope, sometimes referred to as m, would be. Now these are approximations. Is that really, can I tell you that that's specifically -2? No, but I can tell you it's negative. I can certainly tell you it's negative. And it looks like it's a little steeper than 1. So you're going to try to make it as accurate as you can, but these are estimations. They are totally estimations. So how do you make them? Here's the first one. Number 1, use the differential equation to create the slope field. So they tell you that when you're looking at this, when you take x times y, that's going to be your slope. What would it look like on your graph? So the big questions are always, and you always want to think about this, when will, in this case xy, equal 0? Because if it equals 0, then my slope is 0. And if my slope is 0, they're horizontal. I'm going to my margin. I'm going to make you a reminder. Maybe I want to pull this down a little bit so you can write it over here. So this is just, you know this, but just to put it present in your brain. If you have a positive slope, what would that look like? A line with a positive slope goes this way, right? Now, it might be steeper, it might be less steep, whatever, but it's a positive slope. If I'm a negative slope, then I go the other way. If I'm a 0 slope, do you remember Slope Man? Slope Dude? This is 0 fun. 0 slopes here. And then the last kind of slope I have is an undefined slope. It's the worst curse in algebra. Is that what he said? Undefined. There you go, Slope Dude. All right, so what we're doing is we're drawing all these different little slope lines, just little ones, so we can figure out what the function looks like. And so when will xy be 0? When either x equals 0 or y equals 0. Always go for that first. It's going to eliminate a whole bunch of points you got to figure out. So when x equals 0, that is all of these guys. X equals 0, x equals 0, x equals 0. They are all slopes of 0, slopes of 0. And when y equals 0, well, when y equals 0, here it is. All of these would be 0 as well. That just eliminated a whole bunch of points for you to have to figure out. Now, how do you figure out the slopes of the rest of them? Unfortunately, you got to do it by hand by a table. So I'm going to come off to the margin here and see if I can put together a table of values. So I set it up. I have x. I'm trying to get out of my hole punch there. Y. And then I want my slope, which is xy. So I'm going to have 3 columns in my thing, and I've got to go through and I've got to figure out what all these different other ones are. So let's start over here. This is negative 2, 2, negative 2, 2. If I figure out its slope, x times y is negative 4. So I go over here to this coordinate and I put a negative 4 relatively steep slope at that location. And then I'm going to go negative 2, 1. Negative 2, 1. Negative 2 times 1 is negative 2. That slope is also negative, but not quite as steep. Then I'm going negative 2, negative 1. That's this guy. And he's going to be positive 2. Ooh, interesting. So he's going this way. If I go negative 2, negative 2, negative 2, negative 2, I get a positive 4, a steeper slope still. Oh, negative. Hold on. Let me fix me. Going this way. It's a little steeper. And so what you're going to do is go through and figure out the rest of those coordinates. And that's, unfortunately, it's a bit of a journey. If I do negative 1, 2, negative 1, 2, negative 2, negative 1, 1, negative 1, negative 1, and negative 1, negative 2. That gives me negative 1, positive 2. Let me draw those. Negative 1, 2 is a negative 2, so that's this way. Negative 1, 1 is negative 1, not quite as steep. Negative 1, negative 1 is positive 1, and now positive 2, a little steeper. And then I'm going to do the same exact thing for these guys here. And I've got a 1, 2. You can fast forward through this and just do this. All right, negative, I've got positive 1, 1. I've got positive 1, negative 1. I've got positive 1, negative 2. I need to extend my line. So I get 2, 1, negative 1, negative 2. Toss those little slopies on here. Here is 2, 1. Oop, made that a little too steep, but you get the idea. Negative 1 and negative 2. Last ones. When it's 2, I've got 2, 2. I've got 2, 1. I've got 2, negative 1, and 2, negative 2. 4, 2, negative 2, negative 4. And so I am putting these on here pretty steep. Not as steep. Negative and negative steep. There's the slope field. And again, they're approximations. You don't have to, you're not going to be perfect with it, but that's what you got. All right, second one, same thing. You're going to have to go through and figure out. In this case, it's not quite as easy to see when it's going to equal 0 or if it's undefined, because there's always the first questions, because that eliminates you having to calculate more points. This one is going to take you a little time to do. There's a table of values that comes into play with it. Let me real quick set it up for you. I have xy, and then the slope is y minus 2x. All right, for sake of time, let me give you all this. Negative 1, 2 gives you 4. Negative 1, 1 gives you 3. Negative 1, 0 gives you 2. Negative 1, negative 1 gives you 1. Negative 1, negative 2 gives you 0. And then you're into the zeros. 0, 2 gives you 2. 0, 1 gives you 1. 0, 0 gives you 0. 0, negative 1 gives you negative 1. 0, negative 2 gives you negative 2. Then you're into the ones. 1, 2 gives you 0. 1, 1 gives you negative 1. 1, 0 gives you negative 2. 1, negative 1 gives you negative 3. And 1, negative 2 gives you negative 4. And I'm going to go into the next graph here. 2. 2, 2 gives you negative 2. 2, 1 gives you negative 3. 2, 0 gives you negative 4. 2, negative 1 gives you negative 5. And 2, negative 2 gives you negative 6. So what you're going to do is go back and draw all of these on your slope field. So here I go. Now you can take your time and go work your way through this. So this was 4, and then 3, not quite as steep, and then 2, not quite as steep, and then 1, and then 0. And then your your zeros give you 2, 1, 0, negative 1, and negative 2. Next ones give you 0. You got the idea here. Let me just quick draw these. They get steeper, and then I've got a negative, 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 and negative. So you might say to yourself, well, geez, what could the graph look like? If I stay within the cattle chutes like I did up here, here's a possible graph. It could come up like this and then go down. Something along those lines, kind of like a slanted parabola, unhappy parabola at that. So really there's no great way to do these. You always want to find where you've got zeros so that you can figure out where the horizontal lines would be, the horizontal slope fields, and also where it would be undefined. They would be like your key things, but this one doesn't have any of those conditions that would help you out. So you just got to go to the whole darn table of values. There's no other way to generate that. Okay, so then the next question says the figure below shows the slope field for the differential equation, yada yada. Let f be the function that satisfies the given differential equation. Write an equation for the tangent line to the curve through the point negative 1, negative 2. And you're like, that's a whole lot of words. What the heck are they asking me to do? Well, if I go to negative 1, negative 2, I'm down here. That's my coordinate. They want me to write the equation of a tangent line, and you're like, cool. If I want to write a tangent line, then I need a slope and I need a point. Well, they gave me the point, negative 1, negative 2. What's the slope? Well, this is the slope, right? dy over dx is the slope. So the slope is 1 minus xy. Well, 1 minus x of negative 1 times y of negative 2. That gives me 1 minus 2. And I get a slope of negative 1. Can you put together the tangent line equation? Yes, you can. This is old school stuff from millions of years ago. Baby math. Y plus 2 equals negative 1 times x plus 1. And what that means is that you've got a tangent line over here that is tangent to the curve. Now, can you tell from the cattle chutes what the curve looks like? And if I look at it, it kind of curves around like this, and then it goes off. Again, you're keeping the cattle chutes together like this. That's what it would look like. So you want to know what the tangent line is. There you go, you solved it. That's all the notes. So let's pick and choose some examples. Oh, I lied. That's not. There's one more. They want you to match. the graph, this is the slope field, with which equation would that be? What equation would fit that slope field? So I'm going to look at the picture first. And if I look at the picture, one of the things I notice, and here's the things you want to always look for. And again, I've been saying this, where is the slope equal to 0? That would be horizontal tangent lines. And where is the slope undefined? They're the two starting places. If it's undefined, you'll see a vertical tangent line. Or sometimes some books don't put anything. When there's a vertical tangent line, they just leave a blank space there. So you could run into that situation too. So let's go through these equations and figure out where does that happen. Or you can look at the graph and look at it too. So I have this coordinate here. Maybe let's go to the equations. When would this equal 0? So my slope, or dy over dx, equals 0 when x equals -1. So go to -1. Are my slopes 0 there? And you say nope. Okay, out of there. When would my slope be 0 for b? Well, that's when x is 0. So go to when x is 0. Is x 0? Do you have horizontal tangent lines? And you don't? Eliminate him. This one, my slope would be 0. I'll come out this way. Slope would be 0 when x and y are opposite signs, right? When it's +1, -1. Let's see if that works. +1, -1. Ooh, there's a 0. If I go -1, +1. Ooh, there's a 0. So he's definitely a possibility in the midst of this. This one, it would be undefined when y equals 0. Remember, so y equals 0. In other words, you'd have to have, at y equals 0, you'd have to have vertical tangent lines going up and down, and you don't. Take him out of the loop. And this one, you know that the ln of 0, it can't happen. That's undefined. So if I'm at 0, do I have a vertical tangent line? And I don't. So he's out of the loop. This was our guy. So by process of elimination, that's really kind of what you're looking at. All right. Let's pick some practice problems to do. The beastiest on this particular page is number 4. And it's really ugly. And there's no easy way to do it. I guess the one thing that you can do, let's see if we can eliminate some stuff. I know that it's going to be undefined when the denominator equals 0. So let's start with that. Undefined slope m when y equals, when the denominator equals 0, when y equals 2. So when y equals 2, all of those values have to be undefined. Undefined, 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 undefined. Vertical tangent lines. Okay. I know that I have a slope that equals 0 when my numerator equals 0, or x equals -1. Cool. That means horizontal tangent lines. Horizontal, that one's already taken care of by a vertical. That beats it. That eliminates a whole lot of values from my table, because the only other way to get the rest of these values is to put it into a table format. So I'm going to have, I'll try to do this as fast as I can because I don't want to take up too much of your time. 3 things. I have -3, 3. I have -3, 1. I have -3, 0. And then I go to the 2's, -2, 3, -2, 1, -2, 0. Then I go to the 0's, 0, 3, 0, 1, 0, 0. And then I have 1, 3, 1, 1, and 1, 0. All right, let me tell you what they come out to be. You can calculate them. It's just a matter of plugging in the x and the y. This guy's -2, 2, 1, -1, 1, 1/2, 0, 3 is 1. 0, 1 is negative 1. 0, 0 is negative 1/2. I'm kind of running off my page there. 1, 3 is 2. 1, 1 is negative 2. And 1, 0 is negative 1. Put them on your slope field. Here it goes. So I have a negative. I have a negative. I have a positive. I have a steeper positive. I have a positive, a steeper positive, a negative, and a steeper negative. Here we go. And that's what my slope field looks like, based off of my estimations. Kind of a quick version, but you get the idea. And again, they're estimations. They don't have to be perfect. All right, let's pick another one. These are all matching. The easiest thing to do with matching is look for where the slope is 0, look for where the slope is undefined, or the other thing you could do is figure out which equation matches with the picture. Like if I were to draw it, like for example, if I were to find the slope field for this guy, E, that is. If I were to draw, stay within the cattle chutes, stay within the cattle chutes, stay within the cattle chutes, whose derivative is sine? And you would say negative cosine, and that's it, right? Isn't that like a negative cosine graph? Don't they wave the same? So you've got the same wave going on. That means that number 5 is E. So you're just kind of matching them up. You also can make a table of values. Again, you can look for where it's going to equal 0, where you're going to have horizontal tangent lines, where you're going to have vertical tangent lines. All of those things are things that you want to key in on when you're trying to match them. That's not that easy to do. That seems like it's an easy question. Some kids get it quick. Some kids need a little more time. 13 and 14 are easy peasy lemon squeezy, but let's just do 13 since we're on the page here. Consider the differential equation given by this, and its slope field is shown over here. Calculate the derivative at the point 1, 1. Okay, let's do that. If I'm looking at dy over dx and I'm at the point 1, 1, I have xy over 2. That means it's 1 times 1 over 2. I have evaluated that. That's a 1/2. Verify that the results fit the picture. So if I go to 1, 1, 1, 1, that's about this guy. And again, these are estimations. Does it look like that's a positive slope of 1/2? And the answer is sure, it's positive slope. There you go. Good stuff. Pretty much it's positive or negative. The steepness of it you can't generate. You have no idea what that is. Part B. Let f be the function that satisfies the given differential equation. Write an equation for the tangent line to the curve at this place 1, 1. And then use your line equation, tangent line equation, to estimate the value of 1.2. All right, so the first thing you know, you just figured out the slope at that point up above. That's 1/2. And then you've got this point they're giving you that's 1, 1. Can you generate the tangent line equation? Sure you can. That's easy peasy. Tangent is y minus 1 equals 1/2 times x minus 1. And there's your tangent line. They say, okay, now I evaluated it, x equals 1.2. F of 1.2 means plug in a 1.2 for the x. Y minus 1 is 1/2 of 1.2 minus 1. All right, solve it out. Y minus 1 equals 1/2 of 1.2 minus 1 is 0.2. Well, 0.5 times 0.2 is 0.1. So I have y minus 1 equals 0.1. Bring the 1 over. Y is 1.1. There you go. You have just evaluated and estimated what that's going to be. So this is equal to f of 1.2. Don't make it harder than it has to be. They're pretty easy. All right. I think that takes care of. There's a couple more test prep questions after. Actually, no. Just number 15 is a multiple choice. This one you are, number 15, 14 is just like what we just did. Shown above is a slope field. Which of the following is a differential equation? Again, you're looking for where is the slope 0 or where is the slope undefined. And so test some points and you can decide which of these equations actually fits. These are a little tricky. You got to play around with them. It's a process of elimination, which ones don't fit versus which ones do. All right, have a great day, and I will see you in class. Shoot me an email if you've got questions.